So hello everyone, welcome to helpmemath.com. So this time we want to do testing the difference between mean, especially large independent sample. Okay, then we better know what independent and dependent sample means. Okay, so two samples are independent if the sample selected from a population is not related to the sample selected from the second population. So two samples are dependent if each member of one sample corresponds to a member of the other sample. So dependent samples are also called paired sample or matched samples here. Okay, so we want to confirm what that means first. So look at example number 1. Define independent sample or dependent sample. So classify each pair of samples as independent or dependent and justify your answer. Number 1, sample 1, resting heart rate of 35 individuals before drinking coffee. Sample 2, resting heart rate of the same individual after drinking 2 cups of coffee. Okay, so this case, obviously they are doing same 35 individuals with two different cases here. So one is before drinking coffee, second is after drinking 2 cups of coffee. So because we are selecting same samples here, so number 1 case, dependent sample basically. Now number 2 case, sample 1, test score for 35 statistics students, and the sample 2, test score for 42 biology students who do not study statistics here. Okay, so this case, the first one is 35 for statistics students, and then second, so test score for only 42 biology students, but they are not basically taking those one of the 35 students here. Okay, so because they are taking two different population, so number 2 must be independent sample. Okay, so I'm gonna show some examples. So looks like number 2 case in this video. Alright, then let's look at one example. So before solving actual examples, let's try to find out how to set up and two sample hypothesis test here. So for a two sample hypothesis test with independent sample, number 1, the null hypothesis HO is a statistical hypothesis that usually states there is no difference between the parameter of two populations. The null hypothesis always contains the symbol less than or equal to, equal or bigger than or equal to here. And the alternative hypothesis HA is a statistical hypothesis that is true when HO is false. And the alternative hypothesis contains the symbol bigger than or not equal or less here. Okay, but here I'm gonna just underline one thing. So there is no difference between the parameter of two populations. So that's the key point here. So I will explain what that means a little bit later. Okay, set up the null and alternative hypothesis testing. So first we can do HO mu1 equal to mu2, HA mu1 is not equal to mu2. So this case representing two-tailed test. Now number 2, HO mu1 is less than or equal to mu2, HA mu1 is bigger than mu2, so this is the right tail test. Okay, number 3, HO mu1 is bigger than or equal to mu2, HA mu1 is less than mu2, so this is the left tail test. Sorry. Okay, then when you see here, so whatever we define mu1 is always located on the left side, and mu2 is always be on the right side here. So even when you use this some kind of technology, they also indicate whatever you put first column as a mu. I mean the first column is the first independent sample, and the second column is always the second independent sample basically. So please remember that. Okay, now the two sample z-test can be used to test the difference between two population mean mu1 and then mu2 when a large sample, at least 30, is randomly selected from each population and the samples are independent. So the test statistic is x mean x1 minus mean x2, and the standard deviation test statistic is, okay, so that's the formula basically. Okay, so you are using this formula to determine sigma and then z-test here. Okay, so when the samples are large, you can use S1 and S2 in place of sigma 1, sigma 2. So it's like when we do one sample hypothesis testing, the same concept here. So if the samples are not large, you can still use a two sample z-test, provided the populations are normally distributed and the population standard deviations are known. Okay, so that's really important sentences here. So if sample size are not large, which means n is less than 30, even so, if we know the population, the standard deviations, then we can still using the z-test instead of t-test basically. That's what this means. Alright, so this video is just all today, and then I'm gonna just cover each cases from the next video. Alright, so thanks for joining this video, and then I will see you with a different video soon. Alright, thank you.